Solve the equation cosec theta equals -4 for theta between 0 and 360 degrees, giving your answer to the nearest 0.1 degree. Solve the equation 2 cot squared 2x plus 30 equals 2 minus 7 cosec 2x plus 30 for x between 0 and 180, giving your answer correct to the nearest 0.1 degree. Describe a sequence of two geometrical transformations that maps the graph of y equals cosec x onto the graph of y equals cosec 2x plus 30 degrees. Okay, I've got the summary of the question here. So cosec is, let's invert this 1 over sine, so let's invert the fraction then to write sine theta is equal to, and invert this side, we get minus 1 over 4, minus a quarter. And we need to solve this between 0 and 360, so right cast. As is customary, sine is positive here and here, so it's negative here and here. Draw two lines, mark off alpha, the associated acute angle to the horizontal, and simply write sine alpha equals, and drop any negative if there is one to drop. So alpha is shift sine of a quarter. We need to be in degrees mode 3. So shift sine of a quarter then, shift sine, inverse sine of 0.25 equals 14 point, we're doing to the nearest 0.1 degree, 14.5 degrees. Okay, so that's alpha then, so we can read off theta. So the first solution would be around to here, wouldn't it? 180 plus 14.5, 194.5 degrees. And the other solution would be around, right around to here, which is around 360 back 14.5, which is 345.5 degrees. So there's theta then for this one, to the nearest 0.1 degree. Now part 2, 2 cot squared. Well, for part 2, when we're solving this then, let's look at this trig equation. Basically, we need to remind ourselves of the trig identity. So sine squared plus cos squared is equal to 1. Now we want cot, so we want cos over sine. So divide by sine, we get 1 plus cot squared. And 1 over sine is cosec squared, isn't it? When we square it, 1 over sine squared is cosec squared. So now we can substitute cot for cosec squared minus 1 and get a quadratic in cosec. So here, 2 cot squared, so it would be 2 cosec squared minus 2, isn't it? So it's theta. So I'm just going to put in the 2x plus 30. So it's 2 cosec squared minus 2 will be 2 cot squared is equal to 2 minus 7 cosec 2x plus the 30 degrees. So let's just tidy everything up. So what do we get then? We get 2 cosec squared and then we got plus 7 cosec of the angle. And then move the 2 over to be another minus 2 to make minus 4 equals 0. So we should be able to factorize this hopefully. So let's write it. 2 cosec and cosec. It has to be here and here. So we've got those in. So it has to be, what does it have to be? 4 ones? Yeah, 4 goes here. And the 1 goes here. Because that's a plus, we need a plus here and a minus there, and that equals 0, doesn't it? So this tells us, let's solve this then. For this one, we can see that cosec, well, cosec would need to be a half, wouldn't it, for this to work? Cosec would need to be a half, so that means sine would need to be 2. So I'm writing down the sine straight away. And there's no solutions for this because sine never equals 2. And the other one is when this is equal to minus 4, so sine of 2x plus 30 degrees then is equal to minus 1/4, which is what we worked out above, and we worked out there were two solutions. So by the above, 2x plus 30 degrees is equal to these two angles here. So I'll put them in as two possible solutions, like so. Take away 30 both sides then. So we get 2x. The question is leading us to do this, so hopefully everything will work out within the respective ranges. So it's 164.5 and 315.5. Now x we divide by 2. So this would give us 82.3. And this one would give us 307.75, which would be 307.8 degrees. 82.3. But the only worry is, now I've rounded before in the previous problem, and I round once again in half, it might not be the correct answer to the nearest 0.1 degree. So really and truly speaking, we need to work out this angle here a bit more accurately. So let's do that and get these two to confirm that we're on the right track. So we had 14.478. Okay, that's alpha. So let's do a check. Alpha is equal to 14.478. So that would give us then from above the value of theta will be 180 plus that and 360 minus the alpha, isn't it? So theta is equal to, from the above, 194.478. And the other value was 360, take away this, so it's 345.521. So there's our two solutions. So this number goes in here, so it's a smidge under 0.5. So when we get 2x, we take that this is fine with 30 less, and when you divide by 2, it's actually going to be instead of a 5, it's a 47 here. So you're going to get you're going to get 82.2. So we need to change that, 82.2 degrees, isn't it, when we look at the more accurate answer here. And this one, 5.2, is just over 0.5. So when you halve it, you're going to get basically, you're going to get 0.25 there, so you will get the 0.8 there, I think. Just double checking it quickly. Could have still made a slight error, but I think I'm quite more than reasonably happy, although as it illustrates the point that you need to work with more accurate answers before rounding to the nearest 0.1 degree at the end of a problem. So here's the final answers then after the check has been made.